Hiya, this is question 4 of the N25 AASL paper 1. This question is on probability. We have 10 cards numbered from 1 to 10. Rohit draws 2 cards A and B such that this is an integer. You have to be very careful with this question. The first possibility is when each one of them is an integer. And this is the case if A is equal to 0. A is equal to, and this is the case if A is equal to 1 or 4. This is the case when B is equal to 1 or 9. So we have a total of 4 combinations: 1 1, 1 9, 4 1, 4 9. This is not the only possibility. A second possibility is when log base 4 of A, let's say, is a half, and log base 9 of B is also a half. This is when A is equal to 2 and B is equal to 3. Similarly, if log base 4 of A is equal to 3 halves and log base 9 of B is a half, the sum of the two terms would still be an integer. So we actually have 2 more possible combinations: 2 3 and 8 3. So we have a total of 6 pairs of AB that would satisfy the requirements. And we have 10 cards there, yielding a total of 100 combinations of A and B. Therefore, the required probability is going to be 6 divided by 100, or 0.06. Question 5. This question is on integration. Question 5. This question is on integration. We have 3 parts of various levels of difficulty. Because of linearity of integrals, we can split this up into 3 different integrals. First piece, second piece, third piece. The first piece, we can solve this using a u-sub. So if u is x cubed plus 1, du is 3x squared dx. So x squared dx is equal to du by 3. Because we're changing the variable, we also have to change the bounds. X goes from 0 to 2. U, therefore, goes from 1 to 9. So the first integral is equal to the integral from 1 to 9 of a third f prime of u du. Second integral, this guy is a bit easier. You can also do a u-sub for this. So let's say if v is 4x plus 1, dv is going to be 4dx. The bounds for x goes from 0 to 2. Therefore, the bounds for v will go from 1 to 9. This integral then becomes the integral from 1 to 9 of f prime of v dv. The third part can be evaluated immediately. The integral of the derivative is the function itself. So you will get a third of f of u plug in the upper bounds and the lower bound. Similarly, for the second term, the third term, we all know how to evaluate this. So, putting it all together, we are given that f of 9 is equal to 6. From there, we can solve for f of 1. This is the end of question 5. Question 6. This is also a crossover with a higher tier. The idea for this question is to prove that it is monotonically increasing. Because if it is increasing for all x, as we can see on the graph, the derivative has to be positive. This also means that it is invertible and it is a one-to-one function. So let's start off by proving that this is true by taking the derivative of f. We can complete the square for this. And the reason is that we would like to show that this entire thing is positive. This part has to be greater or equal to 0. We need to show that this part is also greater or equal to 0. For all real x, cos of 2x is between -1 and 1. Therefore, we can multiply by 2. And when we add 3, we showed that it has to be between 1 and 5. This is also positive. So we show that this part is also positive. That part has to be positive. Therefore, the sum has to be positive. This implies that f is increasing for all real x. It implies that f is one-to-one or invertible for all real x.